Good evening, everyone. This is Uche, your favorite math teacher. Today we want to look at the square root of perfect squares up to 4 digits. Easy way to find square root of perfect squares up to 4 digits. Now, before we go into finding the square root of perfect squares, we need to know what a perfect square is. A perfect square is an integer whose square root is also an integer. In mathematics, integers are whole numbers. So, perfect squares can be said to be those whole numbers whose square roots are equally whole numbers. Then, we need to study or look at the behavior or the pattern of squares of numbers from 1 to 10. That will be the bedrock of our calculation this evening. Now, the squares of numbers from 1 to 10. When we say square of a number, we simply mean multiplying that number by itself. So, 1 squared is equal to 1, 2 squared is equal to 4, 3 squared is equal to 9, 4 squared is equal to 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81, and 10 squared is 100. So, these are the table for squares of numbers from 1 to 10. Now, watch these. 0, 1, 4, 5, 6, and 9. From this, you can see that whatever we have here, the last digit is either a 0, 1, 4, 5, 6, or 9. So when you have a number whose last digit is not either of these, please, the number is certainly not a perfect square. So let's look at some numbers that we know they are perfect squares, and what we're going to do today only works for perfect squares. So let's see the easy way to calculate, let's say, the square root of 484. Square root of 484. Now the last digit here is 4. When you look at this table, 2 leaves, when we square 2, it leaves a last digit, or the only digit here is 4. When we square 8 again, the last digit is 4. So for the last digit of our answer, it is either going to be a 2 or it is going to be an 8. Now we strike out the first 2 digits. We are left with this one here, which is 4. Good enough, 4 is a perfect square. So the square root of 4 is 2. It simply means we are writing 2 here and we are writing 2 here. Now, our answer is either 22 or 28. This being a perfect square, it is only one that is the correct answer. Now, what do we do? These 2 here, after 2, the next digit is 3. We are multiplying 2 by 3 to get 6. Now, 6 is bigger than 4. As long as we get a product that is bigger than what we have left, then we are going for the smaller number. But if this product had been smaller than what we have here, we will go for the larger number. We are now saying that the square root of 484 is equal to 22. I want to take a second example. Let's look at the square root of 729. Square root of 729. When you look at 729, the last digit is 9. The one that leaves the last digit of 9 is either a 3 or it is a 7. So we have 3 or 7 as the last digits of our answer. We strike out these 2 as well. Now, 7 is not a perfect square. The closest perfect square to 7, that is less than 7, is 4. And the square root of 4 is 2. So our answer is either 23 or 27. Once again, we are going to do 2 times 3 because after 2, the next digit is 3. 2 times 3 is still 6. And 6 is smaller than 7, which means for our answer, we are going for the larger number. In other words, the square root of 729 is equal to 27. Let's also take another example. Let's look at the square root of 361. 361, the last digit is 1. The one that leaves the last digit of 1 is either 1 or it is 9. When you look at this, you have 81 here. So we are saying for our answer, the last digit is either 1 or it is 9. Then we strike out these 2. The perfect square closer to 3, that is less than 3, is 1. And the square root of 1 is still 1. So our answer is either 11 or it is 19. But then, how do we know which one we are choosing? Once again, we have 1 here. So 1 is followed by 2. The next digit after 1, the normal counting, is 2. 1 times 2 is 2. And 2 happens to be smaller than 3. So we are going for the larger number. Therefore, the square root of 361 is equal to 19. This is just but a few examples we want to take on 3 digits. Now we want to look at perfect squares that are 4 digits. Let's see how we are going to produce our answers in a very short time. Remember, we can do this by the long division method, but this one is easier and it's simpler. So let's look at the square root of 3969. 3969. This is a 4-digit number and this is a perfect square. Now the last digit here is 9. 9 leaves, it is 3 that leaves the last digit of 9, or it is also a 7. So for our answer we have either 3 or we have 7. Now we strike out these 2. What we have left is 39. The perfect square closer to 39 is 36, and the square root of 36 is 6. So we have 63 or 67. Now, what do? After 6, the next digit after 6 is 7. So 6 times 7 is 42. And 42 is bigger than 39. So we are going for the smaller number, which means the square root of 3969 is equal to 63. Let's take a second example. Let's look at the square root of 5625. Square root of 5625. Now, the last digit here is 5. And the one that leaves 5 as the last digit is also 5. A 5 squared gives us 25. There is no other one, which means the last digit must be 5. Now, these 2 digits here, we have 56. The perfect square closer to 56 is 49. And the square root of 49 is 7. Automatically, the square root of 5625 is 75. Let us also look at the square root of 9801. Square root of 9801. The last digit here is 1, which means for our answer, the last digit is either a 1 or it is a 9. It is either a 1 or a 9. We strike out these 2. Now, the closest perfect square to 98 is 81. It has to be the one that is less than 98, because we also have 100, but 100 is bigger than 98. So we go by 81. Now, the square root of 81 is 9. So our answer is either 91 or it is 99. Once again, after 9, the next digit is 10. So 9 times 10 will give us 90. And 90 is smaller than 98. So we are going for the larger number. Hence, the square root of 9801 is equal to 99. These are just a few examples. But whatever number it is, as long as it is a perfect square, this method or this approach will help you get your hands on them and your results will show in split seconds. Thank you for your time.